So hello everyone. So finally we are almost going to complete our target or whatever target I had given myself. I'm going to complete it. So this is last session for heat transfers. Once heat transfer will complete, then I will start thermodynamics. I will take three session in thermodynamics. Then thermodynamics will be completed. Once thermodynamics will complete, I will start new chapters, that is from electrostatics. So we'll start electrostatics, and soon I will try to complete whole syllabus of the remaining second part. So I will try to complete each and everything. So I also want to complete it. I'm getting delayed because of some reasons, so don't worry about that. Definitely once I promise to all of you, definitely I will complete each and everything. See, my purpose, what is my purpose, what is my motto? My motto is to share you the thing how I solve the questions. If question comes in front of me, how I close the questions. So if you learn that process, if you learn that method, definitely it will help you out to get good ranks. So let's come back to here. Remaining, we have to complete two topics. One is calorimetry and one is how heat changing takes place. So how temperature change takes place during phase change and in the same phase. So suppose we have ice. Suppose ice, we have ice, minus 10 degree Celsius of ice. This is minus 10 degree Celsius of ice. So first it will come to 0 degree Celsius of ice. Am I right? Yes or no? First it will come to 0 degree Celsius of ice. Yes or no? So what's happening? This is ice, this is ice. So is there is phase change? No. Is there is phase change? No. But what is happening? Temperature change is happening. So delta T is happening. So here we have delta T. So either I have phase, or either I have delta T. So here I have delta T. Now what will happen? Ice will convert to 0. This is 0 degree Celsius of ice. This 0 degree Celsius ice now will convert to 0 degree Celsius of water. So now listen, my friends. This is what 0 degree Celsius of water. 0 degree Celsius of water. So what's happening here? Is there any temperature difference? So if I will ask you, is there any यहाँ पर कोई अपन का temperature difference है क्या? So answer is no, sir. No, there is no any temperature difference. So what is happening here? Here is phase change happening. So this is phase change. This is phase change. So what phase? What phase? Ice is converting into water. Ice is converting into water. So this we say by the name of fusion. So this is fusion. What's happening? Fusion. Fusion. So now come to ice is converting to water. So ice is fusing to water. Ice is fusing to water or melting. Melting. So ice is melting to water. So this is, you can say, melting. So melting, no issue. Melting. Now come back. Water. Now you are giving heat and heat. So what will happen? यहाँ पर क्या होगा? Now the temperature of water will start to increase. And suppose it will goes up to 100 degree Celsius of water. 100 degree Celsius of water. So this is what, listen everyone, this is 100 degree Celsius of water. So again, what is happening here? Delta T. Temperature. So now I am going to explain the formula. So say very well. Temperature changes take place. जब भी अपन का temperature change take place होगा, अपन को आँख बंद करके ये formula use करना है. Q equal to ms delta T. Delta T. ठीक है. ऐसी specific heat capacity. I already explained you everything. ठीक है. But this is when temperature is changing. When temperature is changing. So temperature is changing. If temperature is fixed, if temperature is not changing, temperature not changing. So temperature not changing, what does it mean? Phase changing. What does it mean? Phase is changing. So phase is changing. So जब अपन का क्या होगा, फेज चेंज होगा, तो अपन को क्या यूज करना है? Q equals to m into L. L is latent heat. Latent heat. So suppose here ice is converting to water. So I will use L for melting. And if water is converting to steam, so I will use L for steam. L for steam. Is it okay? So ML. What is L here? L is here latent heat. L is what? Latent heat. So if I will use LF, so this is what? Latent heat of fusion. If I will use L for steam. Steam. So what does it mean? Latent heat of steam. So latent heat of steam. Right? So on will use it. So during phase change we'll use Q equals to ml, and during temperature change we'll use Q equals to ms delta T. ये बात समझ में आता है यहाँ अपन को? ठीक है. So from here also we can get the value of m. Okay, m is q by l. During phase change, no temperature change. Temperature during phase change, temperature is fixed. During phase change, temperature is fixed. Okay, so q by m equals to l. Q by m equals to l. Okay, so during phase change, temperature is constant. Okay, so please make a notes. Okay, during phase change, temperature is constant. Okay, so during phase change, temperature is constant. Clear? So during phase change, temperature is constant. ठीक है, during phase change, temperature is constant. Clear? So this is the thing. Okay, this is the thing. Now everyone listen me. Okay, so now what I am going to do, I am going to representing everything on the graph. So listen everyone. So what's happening here? Suppose we have minus 10 degree. Okay, so this is okay. Let's take this as 0 degree Celsius. No issue. Okay. So we have minus 10 degree of this is minus of 10 degree. So minus 10 degree of ice. This is minus 10 degree of what? Ice. This is what? Ice. Okay, this is what? Ice. So minus 10 to 0. This is what? Minus 10 to 0. This is what? Ice. Can I say? Minus 10 to 0. This is what? Ice. Can I say? Any problem? Anyone having any issue? Minus 10 to 0. Ice. No issue. ठीक है, बात बराबर है. Now this is what? 0. 0 to 100. Okay, so this is what? 0. First 0. So 0 degree Celsius, and this is also again 0 degree Celsius. Okay, so this 0 degree Celsius, this is phase change takes place. Okay, phase changing. What phase changing? Melting of ice. Okay, melting of ice. Am I right? Melting of ice. Okay, so this is ice. Here temperature is changing. Temperature is basically rising. So temperature is rising, and here phase changing, melting of ice. 0 degree Celsius. This is 0 degree Celsius of ice. This is 0 degree Celsius of water. So this is 0 degree Celsius of ice, and this is 0 degree Celsius of water. Am I right? This is 0 degree Celsius of water. Am I right? This is 0 degree Celsius of ice, and this is 0 degree Celsius of water. Okay. Now afterwards what? 0 से अपन कहाँ पर जाएंगे? We'll go to 100 degree Celsius. Okay. Now we'll go 0 to 100 degree Celsius. Okay. So this is 100 degree Celsius. Okay. 100 degree Celsius. Okay. So this is 0 to 100 degree Celsius. 0 to 100 degree Celsius. Okay. 0 to 100 degree Celsius. So my student, this is what? 0, and this is what? 100 degree Celsius. So here again what is happening? Temperature is rising. Am I right? What is happening? Temperature is rising. So 0 to 100 degree temperature is rising. Am I right to all of you? Am I right to all of you? सबको समझ में आता है मेरी बातें? तो यहाँ पर क्या होता है? 0 से 100 डिग्री तक हमारे पास क्या होता है? टेम्परेचर इज राइजिंग. ठीक है, तो यहाँ से 0 से 100 तक हमारे पास क्या होगा? टेम्परेचर राइजिंग. ठीक है, 0 से 100 तक अपन के पास क्या होगा? टेम्परेचर राइज हुआ. तो अब ये टेम्परेचर जब राइज हो रहा है तो उस टाइम पर फेज चेंज होगा क्या? नहीं होगा ना. तो ये क्या है? वाटर ही है. ये पूरा का पूरा क्या है? वाटर ही है ना. ये पूरा का पूरा क्या है? वाटर है. अब 100 पर आप जाकर के फिर से क्या होगा? फेज चेंज होगा. तो यहाँ पर ये भी 100 डिग्री सेल्सियस है, और दिस इज आल्सो 100 डिग्री सेल्सियस. दिस इज आल्सो 100 डिग्री सेल्सियस. ये भी मेरा 100 डिग्री सेल्सियस है, ये भी हमारा 100 डिग्री सेल्सियस है. बट व्हाट विल हैपन हियर? दिस 100 डिग्री सेल्सियस इज फॉर वाटर. So this is water, 100 degree Celsius of water, and this is for steam. This is for steam. Okay, this is for steam. So here what is happening? Phase changing take place. Yes or no? So what's happening? Phase changing. And basically what's happening in phase change? Water to steam. So what is happening here? Water is converting into steam. So water is converting into steam. And what is happening here? Ice is converting into water. So ice, this is the sign for phase change. Here I will use L. Okay, here I will use L. Okay, so here okay, melting, latent heat of fusion, fusing, and here latent heat of steam. Okay, means water is converting into steam here, and ice is melting to water. Okay, so latent heat of, so melting, we will use the concept for melting over here. Okay, so this is the whole diagram. I hope all of you understood what I tried to explain over here. So now okay, so we have time, so we can complete the remaining portion. So listen everyone. So now I am explaining water equivalent. So what is water equivalent? Suppose I have a container made up of metal. Aluminum. Okay, so these containers, I want to replace this container equivalent to water. Suppose this is okay, this weight of this container is suppose capital M, capital M. So I want to replace this container by water. Why? It will help us to solve the questions. But what's happening, suppose inside it water whose mass is small m. So I am raising the temperature of whole body, this container, and obviously whatever the temperature of container will rise, that will be the temperature for water as well. So suppose this temperature is rising by delta T, so obviously this temperature of this container will also rise by delta T. Am I right to all of you? So yeah. तो मैं क्या कह रहा हूँ, what I am saying, what amount of heat I had given to this water, what amount of heat I had given to water. So suppose listen me, suppose if I am saying, okay, if m mass of water I have, this is what m mass of water, listen, so easy. If I have m mass of water and I raise the temperature of water by delta T, and then specific heat capacity is S, so what amount of heat given to the water? Can you tell me, everyone? Can you tell me? So what amount of heat given to the water? Okay, so ms delta T. Can you say yes or no, everyone? So ms delta T is the amount of heat given to the water. Ms delta T is the amount of heat given to the water. Now I want to replace this. Okay, now what's happening? This is m is the mass of metals. Okay, mass of aluminum, suppose. So what I am saying, this is the mass of aluminum. So mass of aluminum. This is mass of aluminum. Okay, and now if I am using aluminum, so a specific heat capacity of aluminum we need to use, yes or no? So specific heat capacity of aluminum, we are raising the temperature by same temperature delta T. Now listen, everyone. So delta T. So see, delta T cancel out from here. So what can we say? This mass of aluminum is equivalent to this mass of water. Am I right? Yes or no? So what I said, whatever amount of heat is given to this container to heat up, whatever amount of heat is given to this device to heat up, okay, whatever amount of heat is given to this aluminum, okay, container, aluminum, okay, corner or surface is, okay, I want to replace this amount of heat by the water. So suppose if I am heating 10 kg of water, if I will get the mass of this, okay, mass of this container equal to the mass of water, so what I will do, suppose the mass of this water is coming, mass of this water equivalent of this container is coming 2 kg. So what I will do, I will add 10 plus 2, 12 kg. So I will do all calculation for water. So no need to write it again. No need to write this metal. Am I right to all of you? Am I right to all of you? So all of you understood what I explained. So see, so from here, this is what water, m is the mass of water equivalent. So this is mass of water equivalent. Okay, so equivalent, okay, mass of water equivalence is what? So this is what we got already now. This is what mass of aluminum divided specific heat of aluminum divided specific heat of water. This is SW. Okay, so this is the mass of water. This is mass of water. Okay. So this is the important relation, so we use in questions, okay, or directly question comes from here, okay. So this is one concept. Another concept we have to cover it out over here. Suppose what I am saying, I had given q amount of heat, okay. So what's happening? Suppose I had given q amount of heat, okay. So to the water, okay. I had given q amount of heat to the water, okay. So I raise the temperature of water. 10 degrees Celsius to 20 degrees Celsius, delta T temperature. So what amount of heat is released? And vice versa. If I will tell you water temperature is falling from 20 to 10, so what amount of heat is, okay, releasing? Okay, if I am adding heat, I am putting heat, so the temperature will rise. So if releasing heat, temperature will fall, yes or no? Do you agree? If I am putting heat to the water, so temperature will rise. So if I am putting, okay, releasing heat, so temperature will fall, vice versa, same thing, same amount of heat, okay. I am excluding all the losses, okay. So yeah, so Q equals to ms delta theta. Suppose delta theta I am using now, so ms delta theta is temperature difference, this amount of heat, okay. Now what I am saying, this amount of heat is utilized, so for suppose, okay, ice, okay, to melting ice, okay. So I want to calculate this amount of heat is released. If this amount of heat is released, okay, by water, okay, by water dropping the temperature of water, or by any means, by any process, this amount of heat is given. So I want to calculate how much, okay, ice will melt. This is mass of ice into latent heat of fusion, LF, yes or no? MLF, okay. So from here, can I calculate m mass? What amount of mass of ice will okay, ice will melt. From here can I calculate? Okay, because this amount of heat, if it goes to ice, it will convert into water, yes or no? This amount of ice will goes to water, yes or no? If this amount of heat will be given used to water. I am assuming the ice is at 0 degree Celsius. Ice is at 0 degree Celsius, yes or no? Because minus 10 degree Celsius is also ice only now. So if ice is at 0 degree Celsius, so from here can I calculate mass of ice at 0 degree Celsius? Okay, is equals to m. Okay, so this is another m. Okay, so what should I do? Okay, I hope you understood. Okay, so I am using q now. Anyway, so q divided by lf, yes or no? Q by lf. So from here, suppose this is okay. Anyway, this is mass. Okay, suppose I am using water, no problem. Okay, or you keep it m naught. Okay, m naught. Okay, so this is what m naught as delta theta divided by L of f. Yes or no? So I hope all of you understood the concept, everything. I tried to explain everything in limited time. I had allotted fixed time to each chapter. I already shared with all of you. So I'm trying to complete the full syllabus, okay, of your examination point of view. I'm trying to complete wide and full syllabus. I will not leave anything. Once our syllabus will complete, then we'll start another session. So I already shared my plan. What is my plan? So I appreciate your thoughts. I appreciate your advice. I appreciate everything. Okay, so thank you for everything. Okay, so thank you.